This video will introduce you to the concept of a stack data structure. Data structures are broadly classified into two types, linear and nonlinear. A stack is an example of a linear data structure, along with arrays and queues. A stack is a linear data structure that follows the LIFO principle, which means last in, first out. Insertion and deletion are only allowed at the top. Think of a stack of plates or books, where the last item placed on top is the first one to be removed. Stacks have numerous applications, including function calling and recursion, expression evaluation, parentheses matching, undo/redo operations, browser history, and memory management. Let's look at how a stack works with function calls. When main calls first and first calls second, the functions are pushed onto the stack. They are popped off and executed in the reverse order they were called, following the LIFO principle. Recursion also uses a stack. For a factorial example, function calls are pushed onto the stack until the base case is reached. Then, they are popped off one by one, and values are calculated and returned. The main stack operations are push, which inserts an element at the TOP, pop, which removes the top element, peek top, which displays the top element without removing it, is empty, and is full for checking the stack status. The push operation inserts a new element at the top of the stack. The top pointer is always updated to point to the most recently inserted element. The pop operation removes the element at the top. As elements are popped, the top moves to the next element. The last inserted element is the first to be removed. This is a C++ code implementation for the stack push and pop operations. The push function checks for stack overflow before inserting, and the pop function checks for stack underflow before deleting. This slide shows a more comprehensive C++ implementation of a stack using an array, including the display, peek, isFull, and isEmpty operations, along with examples of their use. The time complexity for push, pop, and peek operations is 01, because they only operate on the top element and require no traversal. The display operation, however, has a time complexity of ON, because it requires traversing all n elements in the stack. This table summarizes the time complexity of the main stack operations. Most operations are O1, meaning constant time, while the display operation is ON, proportional to the number of elements. The space complexity of a stack is ON, where n is the number of elements stored. This is because the memory requirement increases with the number of elements in the stack. Advantages of a stack include simple implementation, efficient insertion and deletion, and usefulness in recursion. Disadvantages are limited access to only the top element and the possibility of memory overflow.